Before I get started with my presentation, I want to ask all of you, have you all been vaccinated? Because thankfully, with vaccines, we're starting to win against this pandemic. But are we ready for the next? Because now it's our responsibility to make sure that we are ready for what comes next in the future. And today, I want to help us prepare for the next pandemic with DEVIN, a dashboard for the epidemiology of viral infections. Let's go back a few years, around 2018, where a group of researchers were very interested in a new strain of influenza, very concerned that it would cause a new epidemic. And in the latter years, it did, but not because of influenza, but because of SARS-CoV-2 that caused the COVID-19 pandemic that the world, along with the Philippines, were woefully unprepared for. In fact, to date, there are over 1.5 million cases and over 26,000 deaths. And unfortunately, that is not the end of it, because the next pandemic is not an if, but a when. Thankfully, though, we can prepare for it. How? Well, we have data on our side. Speaking of data, let's go ahead and take a look what we have. We can take a look at our viruses that are present in the Philippines, care of NCBI and UNIPROT databases. And then let's focus on the target genes that make them virulent. And aside from the viruses, let's take a look who and where they infect. Let's focus on the region level of the Philippines, focusing as well on other factors such as population, as well as the healthcare capacity, care of DNR, PSA, and the Department of Health. What do we do now with that data? Well, DEVIN will first create clusters to determine what risk is being posed. And then we're characterizing the regions to determine how they are vulnerable to these risks. And then finally, based on these characteristics, we cluster them so that we can prepare proper recommendations tailor fit for each region. Let's dive right in. For viruses, we first started collecting at the genome level and then going to collecting their query cover and GC content. So, how did we go from this to this? Well, first off, again, we did local alignment sequencing of each virus gene, and then we grouped them together based on their virulence factors. So in total, we have 5 virulence factors that we consider when we do our k-means clustering. Aside from that, we also took a look at their virulence score, which is just a very intuitive way to determine or compare with each other how they are more virulent. Now let's take a look at what clusters we had. So we're able to generate a total of 4 clusters. Our first cluster we can refer to as our virulent cluster. So this cluster is very efficient at causing diseases because of their elevated mutation rates and because they make use of polyproteins, which means they're very efficient at infecting hosts and causing these severe diseases. A great example is our dengue virus. The next cluster are the infectious clusters. Unlike virulent clusters, these are more geared towards just infecting the host, but not necessarily causing severe symptoms. Perfect example again is of course SARS-CoV-2, which we know is highly infectious, but not exactly as fatal. Our third cluster is our replicative cluster. So this cluster is very good at integrating itself within the host. So once it infects, it has all these assembly proteins that help it integrate and infect the host further. Again, perfect example is our MERS-CoV. And our final cluster is our robust cluster. So this is our sturdy cluster because of their high encapsulation factors that make them very resistant to different disturbances, whether these are genomic or environmental. Now that we have our clusters, let's take a look at where we can find them by taking a look at the regions. So for this method, we took a look at all the databases that had species observations and then comparing it with the region demographics. So now, how exactly did we want to go from virus species and then to region characteristics? So this is what we did. So with the virus clusters, we listed all of the potential hosts that they had. And also for all of the regions, we listed down where each species of these hosts occur. So whether these are provinces or regions. Then we group them together so that we could count how many times each host appears in each region. And from there, we group that together with other region demographics such as the healthcare capacity, population density, and the mortality rate. And this is what we use to cluster for our regions. Leads us to our next step where we put it all together. So here we have our final data, which we will use to generate two types of characterizations of our regions. First is we want to categorize how we generate our recommendations and interventions. And then we want to categorize their level of viral risk. And that is what we give to Devin so that he can generate a useful dashboard. Aside from that, we can also make use of an exposure and vulnerability score. The exposure score is just an idea of how many host viral clusters are available based on the weight of their virulence score, while the vulnerability score is how vulnerable are the regions based on the mortality and the population density divided by the healthcare capacity, because it's shown that as your healthcare capacity increases, your vulnerability score should decrease. All right, let's go ahead and take a look at our first group of clusters. We're able to generate a total of 5 great cluster regions. So our first cluster region is very obvious, overcapacity. It's where the healthcare capacity is not enough to meet the infection rates and of course the mortality rates. A prime example of this is NCR. Our second cluster is the marginal capacity. Very similar to the overcapacity, but the difference is that the healthcare resources is still able to meet the mortality and infection rates, but it's borderline between not being able to cater to these infection rates. Again, an example of this is ARMM. Our third region is our susceptible regions that although they have very good healthcare capacity, they are highly susceptible to the viral clusters that pose very severe symptoms, and that causes a high mortality rate in their population. So an example are our region 6. And of course, we have our fourth cluster, the manageable cluster. So this is a very lucky cluster because their healthcare resources and their infection rates are enough so that they can keep their mortality rates at bay. A wonderful example here is region 1. And finally, we have our unrelated cluster. Now, you may notice that this cluster has a very high mortality rate. But the reason why we say it's unrelated, because despite the high mortality rate, their viral counts are not as high, meaning these fatalities may not be related to viral infections. A hint may be because of their high population density or other factors like their healthcare capacity. And now let's take a look at our other way of classifying our regions by risk. So thankfully, we're able to get that by comparing their vulnerability and exposure score. So we have 6 level of classification. So we have our lower bound, which is the non-viral risk. Then we have our low viral and our probable viral risk. And on the upper bound, we have our medium viral risk, high viral risk, and our critical viral risk. Now, where do these all categories come in? Well, here we can see where exactly the priority groups are and how each region is classified based on the type of recommendation that we can provide them. And that's where DEVIN comes in. Finally, we can get the interventions provided by DEVIN. These are based on the CDC guidelines, and they are divided into 3 types. For the individual, for the workplace, school, and community, and finally, for the healthcare system. But it doesn't stop there, because DEVIN can also give us the list of specific viruses that each region is at risk for. And if the DOH or any healthcare institution has made any intervening efforts or vaccination efforts, DEVIN will also provide this. But of course, what better way not to just tell you, but to show you. So this is a sneak peek of DEVIN, and it's a very simple dashboard where the user can input their selected region, and then it will show you different statistics that we mentioned earlier, and then list down the recommendations that were generated. But of course, DEVIN, along with data science and epidemiology, is as much of an art form as it is a science. And iterations will always improve it. So here we have our recommendations and improvement. First off is we should increase our sample size. Let's not limit to a few viruses and increase it to not just RNA, but also maybe to double-stranded RNA. We can also include what other virulence factors we take into consideration and improve the different collection of species occurrences in our regions. We can also try out different methods for alignment and clustering. And more importantly, we can try out or improve the scoring system used for the risk, vulnerability, and exposure. And of course, the interventions that we can provide with Devin can also be increased. And that is it for my presentation with Devin. I hope that this will help us become more prepared, just like I am now prepared to answer your questions. Thank you.